Okay. In the previous lecture, we talked about matrices, and we also talked about some operations on matrices. We talked about these operations, addition, subtraction, those are so easy. And also, we talked about how to find the transpose of a matrix. We talked about transpose of a matrix. We also talked about a determinant of a matrix. And finally, we talked about how to find the inverse of matrix. That's all what we talked about in the previous lecture. We now talk about linear system. Here, in this lecture, we talk about how to solve a linear system by using operations on matrices. Okay? We say a linear system is a finite number of linear equations. If you have more than one equation, one linear equation, it's called linear system. As you see here, we have more than one linear equation, and this all together called linear system. This is a linear system. As you see, the exponent of all variables, look, the power here, all are 1. All the powers are 1. That's why we say it's a linear. If at least one of the exponents is not 1, let's say this is 2. So this equation is not a linear equation in this case. So all the powers must be 1, then we say it's a linear equation. And as if you have more than one linear equation, together called linear system. This is a linear system. Here we first convert the linear system to matrices. In the linear system, we have 3 components: variables, coefficients, and the right-hand side constants. Okay? In the right-hand side, we have these constants. We put these all in a matrix, and we name it by matrix B. Here, matrix B is the constant terms, or the constants in the right-hand side. It's B1, B2, up to Bm. This is a matrix. Okay, it's a column vector. Okay, the size of this matrix is M by 1. Is it? You have only one column. Then in the left-hand side here, we get 2 matrices from here. We get 2 matrices. One from the coefficients, and we name it by matrix A. Matrix A is a matrix that we obtain from the coefficients of the variables. Okay? As you see, how many variables do you have in the left? We have x1, x2, x3, up to xn. Okay? At all equations, we have only n variables, which are named by x1, x2, x3, up to xn. And how many coefficients do we have? We have a11, a12, up to a1n. Then we have a21, a22, up to a2n. Then these all. Okay? If you put these constants in a matrix, it becomes A11, A12, up to A1n. Then we have A21, A22, up to A2n. Then AM1, AM2, up to AMN. What's the size of this matrix? The size of this matrix, as you see, we have M rows and N columns. So it's M by N. This is a matrix that you obtain from the coefficients. As I said at the beginning, we have three matrices from this system. One, which is B. Then we have A. We have another matrix. The other matrix is the matrix that we get from the variables. Matrix X, capital X, is the matrix that we get from the variables. How many variables do we have? As we said, N, which are from X1, X2, up to Xn. Okay. Now, this matrix can be written as AX equals B. AX equals B. A here we replaced by this matrix. X is this matrix, and B is this one. We just put these three matrices here. As you see, that's it. This is matrix A, and this is X, and this is B. Okay, we say AX is equal to B. This is the matrix form of the above system. In this system, we have M equations and N variables. Look, A is the matrix of coefficients, X is the matrix of variables, and B is the matrix of constants. That's all, okay? So you should know how to convert a system to matrix form up to now. Then we work on this one, not the system, okay? We work on the matrix form for solving the linear system. Then we have augmented matrix. Augmented matrix is a matrix that we get by combining A and B. Matrices A and B. This is matrix A. And this is matrix B. Combining them in a matrix, we get augmented matrix. This is called augmented matrix. Okay? That's by combining matrices A and B, A is the matrix that we get from the coefficients, and B is a matrix that we get from the constant terms. Combining them in a matrix, we get augmented matrix. Okay? Look at this example. Let's find the augmented matrix for this matrix. Okay? We must first find matrix A, matrix X, and matrix B. Let's find them. What's matrix A? Yeah, it is the coefficients. Okay? A is the matrix that you get from the coefficients of the system. How to arrange the coefficients? The coefficients of the first equation is gonna be the first row. Okay? Coefficients of the second equation is the second row. Then coefficients of the third row of the third equation is the third row of the matrix. Okay? Now, what's row 1 here in matrix A? 1. Look, it's 1. And this is 1. Then 5, yes. And then for the second row, what are the elements of second row? 3, 2, -1. Yeah, or -1. 3, 2, -1. These are 3, 2, here it's -1. How about the last row? 2, -4, 1. This is A. Okay? Times X. What's X? The variables. How many variables do you have? You got all the equations. In the first equation, we have x1, x2, x3. In the second also, and in the last as well. Okay? In all equations, we have the same number of variables, which are x1, x2, and x3. So what if we have x4 here also? That means the number of variables are 4, which are x1, x2, x3, x4. Okay? So, yeah. I said if we have x4 here also. If we have that. Okay? Even if it's not in this equation, it's okay, no problem. We count it. Here, it's x1, x2, x3. It's equal to what? Equal to b. What's b? The constants. 5, 10, 8. 5, 10, 8. This is the matrix form of the system. So what's the augmented matrix? Augmented matrix is A, B. Okay? As the matrix A, then we write down matrix B as the last column. Let's write down matrix A the same. 1, 1, 5, 3, 2, -1, 2, -4, 1. Then we write down B as the last column, which is 5, 10, 8. This is augmented matrix. This is augmented matrix. Or you can separate them by this vertical line. That's it. Do you have any question about this? It's so easy. This is matrix form and this is augmented matrix. Then we have row echelon form. We say a matrix is said to be a row echelon form if the following conditions are satisfied. First, all 0 rows, if any, are at the bottom of the matrix. That means if we have a row in which all its entries are 0, it must be in the bottom. Okay? It must be at the bottom. And if 2 successive rows are non-zero, the second row starts with more 0 than the first, moving from left to right. Look, I'm going to give you an example for these 2 points. We say a matrix is said to be a row echelon form. Here we have row echelon form and also reduced row echelon form. It's different from this. Okay, it's similar, different. It's actually not too different from this. Reduced row echelon form must satisfy these 2 conditions and 1 more condition. Okay? But for row echelon form, we say a matrix is said to be a row echelon form if it satisfies these two conditions. First, all zero rows, that means if you have a row in which all its elements are zero, must be at the bottom of the rows. For example, if you have 2, 3, 2, 3, 0, 4, let me check. 4, 4, 0, 0, 0. Look, as you see, we have this row in which all its elements are zero. It must be at the bottom. What if this here 0, 0, 0, 3, 3, 2? How about this one? It's not row echelon form, because here you have this row in which all its elements are zero, but not at the bottom. It must be at the bottom. Then we say, as you see, the first row, the first element of the first row is 2. Okay? If in the second we have 0, 3, 2, and in the third one we have 4, 2, -1. Is it in a row echelon form? About 0, it's okay, because we have no row in which all its elements are 0. Okay? It's okay. It satisfies the first condition. We say if all elements are 0, then it must be at the bottom. But here, it's only one of the entries is 0. So it must not be at the bottom. Okay? It could be somewhere else even. Now, here it satisfies the first condition. How about the second condition? Look, if it satisfies the second condition or not. We say for each two successive rows, okay, if the first one starts with non-zero element here, okay, the second one starts with non-zero entry at the same level at here or in the right. It says if two successive rows are non-zero, the second row starts with more zero than the first one, from left to right, if you count it. As you see, the first one, as you see, starts with non-zero from here. How about the second one? It starts here. Okay, so it starts with more zero than the above one. Okay, and here if we have 0, 0. How about this one? It's okay. Starts with non-zero here. Okay. For these two rows, these two are successive rows. These two are successive rows. These are two successive rows. As you see, the second row starts with more zero than the first one. Okay? That's it. Now, let me tell you, easier. We say if we have, for any two successive rows, the leading term of the below one must be in the right of the above one. Leading term, what's the leading term? It's the first non-zero entry. The leading term here is this one. And the leading entry actually, not leading term. Leading entry here is 3. It's the first non-zero entry. It's the first non-zero. يا كم جمالة كصفر نبت. Okay. So what's the leading entry here? Is -1 because these are 0. We don't count these. So this one is the leading entry. As you see, the leading entry of this one is in the right of that one. And the leading entry here is in the right of the above one. Okay? It must not be in the left. It's possible to be directly below it. So what if we have, let's say, -1 here? It's possible? Yes, it's possible. It's possible to be below it. As I said, I just said that. It's possible to be below it, but it never be in the left. Okay? Look, here, if this is 0, 2, 1. Is it possible? No. As you see, the leading term here is in the left of that one. Okay? It's in the left of the above one. 0, 3, let's say 2, no. What if this is, let's say, -2? Is it possible? Yeah, it's possible. Okay? It's impossible to be in the left. Okay? If it's in the left, we say it's not on row echelon form. Okay? So the leading theorem here is this one. The leading theorem here is this one. The leading theorem here is this one. As you see, the leading theorem here, the below one, it's exactly below it. It's possible to be below it or in the right of it. Okay? What if these two are numbers? 2, 2. How about this one? Is it possible? Yes, it's possible. Look, that's it. This is the general form of this. We now have reduced row echelon form. We say a row echelon matrix is said to be in reduced row echelon form if, in addition, it satisfies. As you see, we have only some additional conditions for row echelon form to get reduced row echelon form. Okay? We say the leading leftmost non-zero entry in each non-zero row is 1, called the leading one. So the leading entry must be 1. Must be 1. The leading entry must be 1. Here, if we have a matrix, as we said, this is 3, 2, -1, 0, 3, 4, 0, 0, 2. What are the leading entries here? For the first row is 3. For the second is 3. For the third is 2. But here, it's okay. It's row echelon form, but it's not reduced row echelon form. Why? Because the leading entries must be 1. The leading entries must be 1. So this 3 must be 1. This 3 must be 1. And this must be 1. Then we say it satisfies the first condition of the first extra condition of the reduced row echelon form. Then we have another condition. It says in the column that you have the leading entry, there must not be any other entry in that. All the other entries in that column must be 0. Look, This is a leading entry. And in this column, we must have only that entry which is non-zero. Now it's okay. For this one, this is one. In the column, do you have any other non-zero entry? Yes, 2. So that 2 must be 0 also. That 2 must be 0. This is a leading entry. In this column, we must have only this non-zero entry. We have these two non-zero entries, so these must be 0. Now, as you see, this is the matrix in reduced row echelon form. This is the matrix in reduced row echelon form. Here we have some examples, as you see. Let's only talk about row echelon form. For row echelon form, we have the last 2 extra conditions. Okay? For the row echelon form, look, these two matrices satisfy the conditions of row echelon form. The conditions of row echelon forms first says if we have a row with all entries 0 must be at the bottom. As you see, we have no 0 row here or here. We just have this one, and it is at the bottom. It satisfies the first one. Then the leading entry of each two successive rows, the leading entry of the below one must be in the right of the leading entry of the above one. This is the leading entry, and this is it's in the right. It's okay. And here you have no leading entry. It's okay. So it satisfies both conditions of the row echelon form. This one also. These are the leading entries. That's all. So these matrices are in row echelon form. Must be number 1. It's for reduced row echelon form. I said that. But for row echelon form, it's only row echelon form. If it says reduced row echelon form, of course it must be. And even here, we have this leading entry. This must be 0 also. Okay? Look at this one. It's about reduced row echelon form. For reduced row echelon form, it must satisfy both conditions of row echelon form and 2 extra conditions. Okay? The extra conditions are the leading entry must be 1, and the column in which includes the leading entry, there must not be any other non-zero entry. Look, we now have 4 conditions for a reduced row echelon form. We already had 2 conditions for row echelon form, and we also have 2 extra conditions for reduced row echelon form. So it's 4 conditions. First, if we have any, for this one, if we have any 0 row, must be at the bottom. Do you have it? Yes, it's in the bottom. Then, the leading entry for each 2 successive rows, the below one must be in the right of the above. Look, this is the leading entry. This is the leading entry. As you see, the below row, its leading entry is in the right of the above. It satisfies the second. Then, each leading entry must be 1. What are the leading entries? This and this. So both are 1. It's the third condition. Now, in the column in which we have the leading entry, all the other entries must be 0. This one is. And here also, we have leading entry. This satisfy? Yeah. So this is reduced row echelon form. For this one, it's the same. So these two matrices are in reduced row echelon form, but these two are not. These are not in reduced row echelon form. For the first one, why this matrix is not in reduced row echelon form? You have some reasons to say that, it's not in reduced row echelon form, because you have this 0 row which is not at the bottom. Okay, and also the leading entry here is not 1. You can say that also. And even you say this leading entry, we have another non-zero in that column. Okay, and even here, this is 1, and it's not 0. All of the elements in that column that you have the leading entry must be 0. So you have many reasons to say that it's not in reduced row echelon form. How about this one? Why? There isn't a 0 row. Look, first we say it's not 1. It must be 1. Okay? The leading entry must be 1. And here you have for this leading entry, for the next row, we go on to the next row. This is the leading entry. The other elements of this column are not 0. As you said, they must be 0. Okay? So that's why it is not in reduced row echelon form. This one? Look, here, this is not leading entry. Leading entry here. أو إليمنتية أو جمارية كلا تشبه بسر جمارة كان بروين 0 نبي يا كم دانك 0 نبي أميت يا نبي أميت يا نبي هل نبي بو لبروين مدوه إمامي بيك شو قال له وش جيبه جك أي خلير أما يكان أما أنا 0 نين ونيا إيه نابت أجر أميت يا نبي ونيا أجر أما شريك بيت أما شر 0 بيت بس أما 2 بيت نابت بو لبروي leading entry أمرويا أمي أيوش أبيك بيت okay it's not on this row echelon form okay do you have any questions okay سيكا إما reduce row echelon form معها شوار شرط مان هي لسه شرط يكن على أجر هاتو رويك ريسك همو إليمنتك يعني 0 أبي اللي خواري كيف خواري أما شرط يكن شرط يدوم على أجر هاتو دوروم هو بدوابدويك دوريزم هو بدوابدويك أبي leading entry شيء جال بس أنا leading entry شيء يكم جمارية كبي أجين كصفر نبي الروي ليرة بس ليرة الروي يكم جمارية كصفر نبي شيء دوا طب أما في أثري leading entry باشا ليرة يكم جمارية كصفر نبي شيء بمشي أما leading entry على leading entry بعتبره خوال أبي leading entry كان كونه لا راس برو لا راس أما شرط السيم على همو leading entry كان أبيك بنيك نابي سدير عمل leading entry نابي سدير أبيك بيت باشا أبيهم يعني يكبر شرط كوتاي أو كولومي كليدين انتريت يا يسبون نلير أما ليدين انتري باشا دوا نابي لم كولومي هيج جماري كترم هاي أبي همي صفر جقالو جماري جقالو يك ويا بيك باشا سيري سلو أو سلوكا لير جوان تبدي أنا أجا سيكين أجر همي صفر بك وتو تخوار أما شرطية كم يجي وجه ليدين انتري كان دياريك حتى برو خوارو برو برو راس برو لا راس برو ونيا أوش جاب جاك شرطي سيم أم دول ليدين انتري كهما هاردو كان يكن بالا يكن انجا أو كولومي كأم ليدين انتري تيايا همو إليمنت كان كي صفرة بالا أي بو مان أميش بهما شو تعالوا عندنا شو okay we now have elementary row operations. Here we have 3 operations that we do on the rows to convert a matrix to reduced row echelon form. Okay? First, we can swap 2 rows. We can swap 2 rows. We can interchange 2 rows. For example, here, we can move this to here and that to there. But all the row together, this, we can bring this to down and this to up. Okay? It's swapping 2 rows. You must interchange all the elements. Okay? You couldn't interchange 2 to 3 elements and not others. You must interchange all elements between those 2 rows. It's the first operation that we could do on a matrix. Then we can multiply or divide a matrix by a non-zero scalar. For example, here, to change this 3, as we said, it must be 1. Is it? We said this must be 1 because it's a leading entry. We can divide or multiply a row by a non-zero value. How to make this to 1? Dividing by 3. Look, we divide all elements of the row by 3. We don't divide only that entry. We must divide all the elements in the row by that number. Okay? If we divide all the elements by 3, what we get? Let's check. This becomes 1. This 3, if we divide it by 3, we get 1. Is it? This is 1. Okay? For the second one, 2 dividing by 3 is 2/3. And here, 1 dividing by 3 is 1/3. We get this. If we say R1 dividing by 3, why do we do this? To change this to 1. Okay? If you want to change an entry to a value that you want, you could multiply or divide by a value, but the value must not be 0. You cannot multiply or divide by 0. Okay? That's it. It's the second operation that you could do on a row. Then we add a multiple of a row to another row. We can multiply a row by a value and then adding to another row. As we said this is 2. So all the elements here must be 0. Must be 0. But this one is not. How to change this to 0? Look, we don't multiply or divide by 0. How to change this to 0? From the leading theorem, we can change this to 0. Okay? The leading theorem is in the second row. What should we multiply by this entry and adding to this one to get 0? We say R1 becomes R1 minus R2 by subtracting this entry from that one, we get 0. It's how to make an entry to 0. You don't multiply by 0. Okay? What we do, by using the leading entry, we can make it 0. بهوي leading entry كو أواني السلوك واري خوي بكين بشي كين بالصفر. ناتي نزربي صفر بكين. شون بكين بالصفر؟ دين أم leading entry زربي تشي بكم؟ لقال أواكوي بكم أوا ببي بالصفر. زربي ناقص كواته بشي. أما أم شماري كأمي بكم بالصفر لكان رويايا. It's in the first row, row 1. Row 1 becomes row 1 minus row 2. Ball in row 2. The very leading entry in row 2. Okay? Now, what we do? Row 1 minus row 2. This is 3 minus 0. We do it for all entries. 2 minus 2. 1 minus 0. Now, replace row 1 by these new values. So it becomes, if we do this operation on this matrix, look, row 1 becomes, 3 minus 0 is 3. Then 2 minus 2 is 0. 1 minus 0 is 1. Then row 2 is still the same. 0, 2, 0. Then 0, 0, 0, 0, 0, 1. It's how to make an entry to 0 from the leading theorem. Okay, by using the leading theorem. This is the third operation that you could do on the rows. We say we can multiply a row by a value, then adding to another row. Okay. Look at this here on this example. We have these 3 operations. We apply these 3 operations on this matrix. Here we have this linear system. For this linear system, the augmented matrix is the matrix which is obtained from matrix A and matrix B. A is the coefficients and B is the constants. That's it. This is augmented matrix. Now, if you apply these 3 operations on this matrix, let's see what we get. We said first we could interchange 2 rows or 2 columns. Let's interchange row 1 and row 3. Only 2 rows. Okay? Even if they are not successive rows, you could interchange their places. To interchange row 1 and row 3, or to swap row 1 and row 3, row 1 comes to down and row 3 moves to up. Okay? what we get? The matrix becomes, first we have row 3, 1 minus 4, 2 minus 1. As you see, the third row comes to first. The third row comes to first. And the second row is still the same, still at the same location. 3, 2, -1, 4. We haven't swapped it with any other row. So it's still at the second row. And row 3 becomes row 1. Sorry, I mean row 1 moves to down to row 3. So now we'll replace row 3 by 2, 1, 1, 7. As you see, we just swapped rows 1 and 3. Can we do more swapping? Yeah. Yeah. You can do more interchanging rows. 1, 2, 2, 3, 1. Okay? You still can't interchange 2 more rows. Okay? That's it. It is the first operation that you could do on matrices. That's it. Let's do it. Then let me just write down it. R1, R3. This means interchanging or swap. It becomes 1 minus 4, 2 minus 1, 3, 2 minus 1, 4, and then 2, 1, 1, 7. That's it. This is the matrix after interchanging row 1 and row 3. Then, can I do more operations on this matrix? Yeah. We can apply all the operations, all the 3 operations, more than once on the same matrix. Okay? Let's do another operation on this one. On this one. Let's divide the first row by 2. Can I do that? Yeah. And also you can divide the second row by 3. The third row by any value you want. Okay? Or multiplying. Let's multiply row 1 by 2. We say 2 R1. What we get? We just multiply the elements of R1 by 2. R1 means row 1. How about row 2 and 3? Still the same. We don't make any change in those 2 rows. We just have changed the elements of row 1 by multiplying them by 2. So if you multiply the elements of row 1 by 2, what you get? 2 minus 8, 4, and -1. Okay? Sorry, -2. Yeah. We multiply all the elements by 2. Can I do 3 row 2 also? Can I say that? Yes. You can do also. You can do at the same time, you can multiply or divide 2 rows by values or by any number. Okay? Then if you multiply row 2 by 3, let's divide row 2 by 3. Row 2 by 3, dividing it by 3. What we get? 3 dividing by 3 is 1. Then 2 dividing by 3 is 2/3. -1 over 3. Then 4 over 3. Okay? Now, how about the third row? We don't make any change in it, because we had only operations on row 1 and row 2. So row 3 is still the same, which is 2, 1, 1, 7. That's all. Here, I'm just going to explain how could you make these changes, because we need it in solving linear system by using Gauss elimination and Gauss rule. Okay? We use these operations. We just follow these 3 operations to do everything to solve the linear system. No, I'm not going to ask you to change, but you should do the required changes. Okay? I'm going to tell you what should you do. Okay? That's the second operation. Yes, you can. You can, yeah, you can multiply or divide the third one also. Okay? This is the second operation. How about the last operation? The third operation that we do, we can multiply an entry, a row, by a value and adding to another row. And adding to another row. Okay? Look, this one, let's say it's 4. If this is 4, okay? This is 4. Look, we have 2 here. If you want to make this to 0, if you want to make this entry to 0, how to do that? If you work on this entry, from this 2, I want to change this 4 to 0. Okay? How? We say this entry is in row 3, is it? We say row 3 becomes row 3. Then this entry is in row 1. أودوي كهمانة كأميبوي أودو شوارع كم الصفر لروية كمان ضربي تشني بكم لقل شوارع كأكل بكم وكات الصفر -2. So we say -2R1. Here, as I said, to change this 4 to 0 from this 2, just look at the rows. Okay? You say this 4 is in row 3. So row 3 becomes row 3 minus what? Minus this entry multiplying by -2 and adding to this one, we get 0. So we say this entry is in row 1, -2 up. And let's see what we get. Let's see what we get. Now we multiply all the elements of row 1 by -2. It becomes -4. Okay? This is 16. Is it? If you multiply by -2, we get that. It's -8. This is 4. Okay? Goran Kari, let's show. In which row do we have changes? In only row 3. Okay? We have no change in row 1 and in row 2 because we do this change in only row 3. We just want to change this entry to 0. So we write down row 1 and row 2 the same, which is 2 -8, 4 -2. Okay, then 1 2/3 minus 1/3, 4/3. That's row 1 and 2. Then in row 3, what we say? It's row 3 minus 2 row 1. So it is, if you multiply entries of row 1 by -2, we get these values. So -4 plus 4 is 0. Then 16 plus 1 is 17. Then -8 plus 1 is -7. 4 plus 7 is 11. Look, we changed this entry to 0. But look, in the other entries of that row, we have changes. Okay? It's how to apply these 3 operations on rows. That's it here. These rows interchanged. Row 1 is -3 row 1. Row 1 multiplied by -3. And then here, it changed to 0. This entry changed to 0. That's it. Now we have Gauss elimination. Gauss elimination. Listen carefully to this one. If you know this, you know the other methods. Okay? It's the same. It's the same. But here, in this method, we just work on the lower elements of the matrix. But in the next method, we work on both lower matrix, lower elements of the matrix, and upper elements of the matrix in both. It's the same. But we do here the same operation on both, in both methods. And you will have a quiz in this method next week. Okay? Next week, you will have a quiz in this method. Okay? So listen carefully. Look, so for doing this, you should know what are the conditions of row echelon form. Okay? Row echelon form and reduced row echelon form also for next. For this one, if you just know what's row echelon form, it's enough. Okay? For the row echelon form, we have 2 conditions. Okay? We said if you have a 0 row, it must be at the bottom. And then if you have for each 2 successive rows, the leading term of the second one must be in the right of the first one. That's the conditions for row echelon form. What we do, we say we carry the augmented matrix of the system to row echelon form. That means we convert the matrix to row echelon form. They convert it to row echelon form, not reduced row echelon form, only row echelon form. Then assign the non-leading variables as parameters. We assign the non-leading variables as parameters. Here, if we have more than one solution, you do this one. Okay? That in this case, you say if the number of equations is less than the number of variables, we do this one. Number of equations is less than number of variables. If the number of equations is less than the number of variables, we do this. We assign the non-leading entries by parameters. Then we solve leading variables by using back substitution. We do substitution from bottom to up to get the value of all variables. Look. These are the operations that we could do on the matrix. That's all what we did before. Look at this example. It says solve the system of linear equations by using Gauss elimination. Okay? The first method is Gauss elimination, so that's why we should use Gauss elimination for solving this linear system. What we do first? First, we need to write down the augmented matrix. We need to write down the augmented matrix. Okay? What's the augmented matrix here? It's the coefficients and the constants. And it's written down here. This is the augmented matrix. Okay? This is the augmented matrix. Then we apply the three operations: interchanging rows, multiplying or dividing a row by a value, and also multiplying a row by a value and adding to another row. We just apply these three operations to change this matrix to row echelon form. Here, it's easier just to make it easier. If we move this to off, that means here it's easier if the leading entry here is 1. It's easier. Even if it's 2, it's okay. Okay? You can work on this one. But it's easier to work on 1 than other values. Okay? Let's first interchange these two rows. We interchange these two rows, row 1 and row 3. Okay? If you interchange them, what we get? We get this matrix. As you see, it's only by interchanging row 1 and row 3 we get that matrix. Now, what we do to convert this to row echelon form, what we do? We say this is the leading term. We make these two to 0. We make these two to 0. Okay? We just try to change all the lower matrix to 0. Look, this is the lower matrix, and this is the upper matrix, upper triangular matrix, and this is the diagonal. Okay? This is diagonal. We have lower, upper, and diagonal. Okay? What we do? We just try to change these to 0. In Gauss elimination, we just change these to 0. Okay? How to change this to 0? From this one, by that one. How to change this to 0? By that one. So from the first leading entry, we change all the below entries to 0. From this one, we change this one to 0 and this one to 0. These two must be 0. Okay? How to change this to 0? From this one, we say R3 becomes to what? Becomes R3 then minus 3 R1. 3R1. Look, this element, sorry, it's R2, not 3. This element is in row 2, and we want to change it to 0. Okay? We say row 2 is equal to row 2 minus what should I multiply by this and adding to this one to get 0? 3 minus 3. Yeah. Look, in another way, we say we say R2 is equal to minus, sorry, R2 is R2 plus, let's say M, what's this entry? 21 R1. But we R يكون it becomes. Why? What's M21? M21 is it's always minus M interior دابشي أو okay سي دابشي كاتا سنة ناقص okay it's negative 3 over 1 which is minus 3. It's always that. And for this one it is 2 minus 2 dividing by 1. So you multiply row 1 by that value. Okay? So here M21 is minus 3. So R2 is R2 minus 3R1. Let's see what we get. Row 1 is still the same because we have no change in row 1. And row 3 is also, we have no change in it. So we just make change in row 2 because we say row 2 change to row 2 minus 3 row 1. Let's write down row 1 the same and row 3 the same. 1 minus 4, 2 minus 1. Okay, row 2 becomes row 2 minus 3 are 3 row 1. First, let's find negative 3 times row 1. Okay, if you multiply this by minus 3, we get minus 3. This one by minus 3 is 12. This by minus 3 is minus 6. This by minus 3 is 3. Now, we add these for row 2 elements. Minus 3 with 3 is 0. Then 12 and 2 is 14. Negative 6 and negative 1 is negative 7. Then 3 plus 4 is 7. Okay, that's it. Then we can work on this one to make it to 0. At the same step, we can change this to 0 also. What's this entry? It's M31, is it? So M31, we find the coefficient here. We say row 3 becomes row 3 minus M31 R1. R يكو هميشه قاعد بالصفر. R بتاعه بالصفر. Okay? Now we change this entry to 0. How to make this to 0? Yeah, minus 2. It is minus 2 over 1, which is minus. So M31 is minus 2. So it's 2. Okay? That's it. Now, what we do, we multiply first row by negative 2. In the previous step, we multiplied by negative 3 to change this to 0. Okay? To change this to 0, we multiplied by negative 3. But for changing this to 0, we multiply the first row by 2, by negative 2. It becomes negative 2. And this becomes 8, is it? No. Yeah, the first row is changing. Look, we multiplied the first row by negative 2. And we add it to the third row. First, it's easier to multiply first row by negative 2 and see what you get, then adding to the third row. This is 8 plus this, sorry. This multiplying by negative 2 is negative 4. This multiplying by negative 2 is 2. Now we add these to the third row. Negative 2 plus 2 is 0. 8 plus 1 is 9. And -4 plus 1 is -3. 2 plus 7 is 9. That's it. Now, we changed these to 0. These two are 0. So what else should you make it 0? Only this. Okay? Only that one. So we need to change that to 0 also. We need to change that to 0. As we said, this triangle must be 0. We just change these 3 elements to 0. That's enough. Okay? Now, we change this to 0. But here, it's 9. We work on this one, not this one. We don't work on this matrix anymore. Because after changing these 2 elements to 0, we get this matrix. So we work on this one. Don't work on this. Okay? Look, it's given here. We have this matrix. It's the same as the above one. Then we can change this to 0 from which entry? Huh? What's the leading theorem here in this column? 14. Yeah. From this entry, we make this to 0. Okay? From that entry, we make this to 0. Now, how to change this to 0? We say row 3 becomes row 3 plus m, this what? 2 r, which r? R2, because 14 is in R2. Look, this is not a leading entry. That's not a leading entry in this row, because in this column, because this is the leading entry of this row. So you have no more than one leading entry. And here, this is the leading entry. From this leading entry, we make this 9 to 0. Because this is the first, this is the leading entry. So you have no another leading entry here. Okay? Yes. We just try to use the leading entry to make zeros under it. Okay? To make these to 0. Look, from this one, we make these to 0. And from this, we make this to 0. We just work on the leading entries. Now, what's M32? M32 is minus 9 over 14. It's always minus this dividing by this, as we did before in the previous steps. For example, if you want to make this to 0 from this one, okay, this one, it's M23 is equal to what? It's minus this one dividing by this one. Okay? M32 is minus this dividing by this. So this is M minus 9 over 14 R2. That's all. We multiply R2 by minus 9 over 14 and we add it to row 3 to make this to 0. Okay? Do you have any change in row 1? No. In row 2? No. We just make change in row 3. Look, it's divided by 2. is divided by 7, and then it's simply here. It's an extra step here, actually. Doesn't need to do that. Here, M32 is 9/2 here. But in our step is minus 9/14 is the same. Here, row 2 is divided by 7 and then doing that's that step. So that's an extra step, actually. It doesn't need to do. Look, we just do this here and we get the same result. Look, we get 1 minus 4, 2 minus 1. The second row is still the same. 0, 14, negative 7, and then 7. Now, if you multiply row 2 by minus 9/14. Look, this is 14. Sorry. This is 14. If you multiply it by minus 9/14, what we get? Minus 9. Okay? And for this one, 0 multiplying by minus 9/14, we get 0. Then for negative 7. And negative 7 multiplying by minus 9/14. These will cancel out, we get 2. We get minus is plus. 9/2. Is it? It's 9/2. So now, if you multiply this row, and this is also minus 9/2, because for minus 7, if this 9/2, so this one is minus 9/2. And this is minus 9, and this is 0. Now we add these for row 3. Okay? 0 plus 0 is 0. Minus 9 plus 9 is 0. 9/2 minus 3. 9/2 minus 3 is equal to what? Minus 3/2. So it's 3/2. There's 3/2. We just find the common denominator is 2. 2 times negative 3 is negative 6 plus 9 is 3/2. It's 3/2. Then, for the last one, it is minus 9/2. Minus 9/2 plus 9. We add this to this, 9. It equals to what? 18 minus 9 is, it's 9/2. Is it? It is 9/2. So the last entry is 9/2. And let's see what we get. Sorry? It's minus 9/2 plus 9. It's 9/2. Look, the common denominator here is 2. 2 times 9 is 18. 18 minus 9 is 9/2. Look, we get this matrix. We get this matrix. Now, we apply the back substitution to get the values of x1, x3. Let's go to down. That's it. We got this. This is the matrix that you got. In the above one, you got 14 here, negative 7, and 7. It's the same. By dividing this row by 2, you get the same. Okay? You get the same result. If you just divide this row by 2, you get the same result. It's even if this 14, -7 and 7, you get the same values for x1, x2, and x3. You get the same values for x1, x1, x3. Let's work on this one. Here, this is the coefficient of x3. As you see, these are, when we get the augmented matrix from the system, these are the coefficients of x1. Okay? These are the coefficients of x2. And these are the coefficients of x3. Okay? As you see, in the last row, we start from the last row to find the values of variables. Why? Because in the last row, we have 2 zero entries, and you have only one non-zero entry. And we use back substitution to find it. This is the coefficient of which of the variables? x3, is it? So here you have 0x1 plus 0x2 plus 3 over 2 x3 is equal to what? To 9 over 2. And so you can multiply both sides of the equation by 2. These two are constant. So we get 3x3 is equal to 9. So what's x3? We divide both sides by 3. So x3 is 3. You get that? x3 is 3. So x3 is 3. We find it. Now, we need to find the values of x2 and x1. How to get x2? Then we use back substitution. We return from bottom, okay? From here, from the last equation, as we have the most number of zeros, we start from that. So from that equation that we have the most number of zeros in. From this one, we get the value of x3. And then we use back substitution to get the values of x1 and x2. Then we use this equation. Okay? As we did, I'm just going to use the one that we found. It is 14. This is -7. And this is 7. Okay? We haven't divided by 7. That's what we found before. Okay? Before we divide this row by 7, we had this one. Now, in the second row, the coefficient of x1 is 0. So you have no x1. And 14x2. 14x2. This is the coefficient of x2. What's the coefficient of x3? -7x3 is equal to what? To 7. But we already found the value of x3. What's 3? We replaced here. Okay? So you have only one unknown, which is x2. You can find it. As 14x2 minus 7 times 3 equals 7. Then 14x2 minus 21 equals 7. Then move this here. And we get 14x2 is 28, is it? So what's x2? Is 2. So you can find x2, which is 2. Then Which equation should we use to get the value of x1? Equation 1, the first row. Okay, as it's given that we use back substitution. We use back substitution in the last step. We use back substitution to get the values of variables. First, we get the value of x3 from here. Then we use the previous one, the previous equation, to get the value of x2, and then we use the first equation to get the value of x1. Because here we have x1. We cannot get x1 anywhere except here. Now let's find the value of x1, sorry. Here it says x1 minus 4x2 plus 2x3 equals -1. That's it. What's the first equation? What's the first equation? Someone tells me, could tell me. x1 equals -1. But we already found the values of x3 and x2. We say x3 is 3 and x2 is 2. We just replace them by their values. We get x1 minus 4 times 2 plus 2 times 3 is equal to -1. So x1, -4 times 2 is -8. Plus 6 is equal to -1. Then x1 is, sorry, -8 plus 6 is -2. Is -1. Moving this to here, x1 is 1. So the value of x1 is 1. It's the values of x1, x2, and x3. Okay? These are the values of x1, x2, and x3. Yes. Look, here, as I did here, we finished all in 3 steps. Is it? We just finished in 3 steps. In one step, we changed these two to 0. Okay? In the second step, we changed this to 0. And in the last step, we used the back substitution. That's all. So just try to change this to 0. That's all. So let's take a break. Okay, it's enough for this session. Here we have another example. In this example, as you see, how many equations do we have? 3. And how many variables do we have? 4. In this case, we need to assign the non-leading variables by parameters. Okay, we just assign the non-leading variables by parameters. Look at this here. In solving this, we do the same as we did in the previous example. What we do, we first write down the augmented matrix. We write down the augmented matrix. This is the augmented matrix. Okay, these are the coefficients and these are the constants. Okay, now from this augmented matrix, what we do, we start from this element. All the elements below this entry must be 0. Is it? We did it the same before. Okay, all these elements must be 0. So we apply the operations to change these two elements to 0 from this one. Okay? How to change this to 0? This element is in row 2. We say row 2 becomes row 2. Then we change this to 0 from this one, from that element. What's this row? It's row 1. It's row 1. Okay? Which say it's R2. What should I multiply to this one and adding to this to get 0? Just minus row 1. That's all. Then by this operation, by this changing, we get 0 here. We get 0 here. Let's do it. Let's write down the matrix that we get. Okay. The first row is still the same because we haven't made any change in row 1. So we write down the same. 1, 2, 3, 4, and 10. Okay? Then, in the second row, what we did? We just subtract row 1 from row 2 to make this to 0. Okay? To change that entry to 0. We say row 2 minus row 1. 1 minus 1 is 0. Then 2 minus 2 is 0. 4 minus 3 is 1. 5 minus 4 is 1. 8 minus 10 is minus 2. This is the second row. Can we do some operations on row 3 at the same step? Yes. Okay. We change this to 0 also. We change this to 0. Be careful. You cannot do the same. You cannot do two operations on the same row at the same step. Here, we cannot do another operation on row 2. Don't do that. Okay? But as you see, we applied an operation on row 2. And you can also apply an operation on row 3. What should we do in row 3? We need to change this to 0. As I said, this is the augmented matrix. We start from this element. This is the first leading entry. Okay? All the elements below must be 0. Then we seek for next leading entry. And we need to change all the below entries to 0. We changed this to 0. And now we need to change this to 0 as well. Okay? We need to change this to 0. How? We say row 3 is row 3. Row 3. What should I multiply by this? And adding to this one to get 0. Minus 2 what? R1. Because this element is in R1, we say minus 2 R1. Kursiyle niye? Ya onu kursiyle. Jenny de işte kaka. This is the operation that we apply in row 3 to change this into 0. Now, what we get? we multiply the elements of row 1 by -2. If we multiply this by -2, we get -2. This by -2 is -4. This by -2 is this. Now, we add these to the entries of row 3. -2 plus 2 is 0. Is it? Then, -4 plus 4 is 0. -6 plus 6 is 0. -8 plus 8 is -20 plus 20 is 0. So this row becomes 0 row. Okay. Now we have this matrix. We get this matrix after doing these two operations on row 3 and row 2. That's it. We get this matrix. This is the matrix. Look, this is done the same as we did in the first operation. That in the first step, this changed to 0, and in the second step, this changes to 0. That's it. Okay, but we did these two steps together. You can do it, and you can do separate. Okay, both are acceptable. You can do both steps at the same step, or you can separate the steps. And now we get this matrix. After doing those two steps, we get this matrix. This is, okay, is it on echelon form or not? Yes, it's on echelon form. If there is any 0 row, it's in the bottom. Okay, and also the leading entry of any 2 successive rows, the below one is in the right of the above. Okay, that's both conditions of row echelon form. So it's on row echelon form. In this case, we assign the non-leading variables by parameters. We assign the non-leading variables by parameters. Here, this is leading parameter, and this is leading parameter. Okay? This is x1. This is x2. This is x3. This is x4. Which of the variables is not on the leading entries? X1 is at the leading entry, and X3 is at the leading entry. So what else do we have? X2 and X4. We'll get X2 to be a parameter and X4 to be another parameter. Let me check which parameters it's used here. X2 is S and X4 is T. In this case, just equal those which are not leading, which are not on leading entries, these two, sorry, X2 and X4. As you see, X2, we have no leading entry here. For X4, we have no leading entry here. We just replace X4 and X2. We just let X2 and X4 to be a parameter, S and T. Okay? If X4 to be T. Look, if this is T. So this is 1x3 plus 1x4 is equal -2, is it? But here we let x4 to be T. we let x4 to be t. So x3 plus t equals minus 2. If we move this to the other side, what we get, x3 is minus 2 minus t. This is x3. Okay, we said let x2 to be s and x4 to be 2. ليه بو x2 x4 بكاري هنين بومدو parameter بو نعلم x يكو x سي بار لبر اوي x يكو x سي لأسي لدين كتير مكان اما امانا اقل لدين انترينا بون لأسي لدين انترينا كان او كادتوان او هكين با parameter كان بلان تشكاتك اما اكين تشكاتك اما يكسان اكين بparameter اگر هاتو جماري هاوكيشكان if the number of equations is less than the number of variables. How many equations do we have here? 3, but one of them is 0. Okay, so we have 2. Is it? We have 2 equations. How many variables? 4. So the number of variables is more than the number of equations. In this case, we need to assign parameters. Okay, that's it. And for x1, we just replace x4 by t, x2 by s, and x3 by minus 2 minus t to get the value of x1. That's it. And this is x1. This is x3. And we let x1, x2 and x4 to be s and t. So these are the solutions for that system. These are the solutions for that system. Okay? So this is all about the first method of solving a linear system, which is Gauss elimination. And then we have Gauss-Jordan. Gauss-Jordan elimination. It's the same, but we have more steps. Okay? We have more steps than before. For Gauss-Jordan elimination, what we do, we convert the matrix, the augmented matrix, to reduced row echelon form matrix. We need to reduce we need to convert the matrix to reduce row echelon form. We have 4 conditions for reduced row echelon form matrix. First, we say yes, the 0 rows must be at the bottom. Then, sorry, yes, and the column that you have reading entry must all 0. Then, yeah, yes, for any 2 successive rows, the leading theorem of the below one must be in the right. Okay, that's 4 conditions of reduced row echelon form. As you see, that's it. In the Gauss elimination, we just did it. If this is the augmented matrix, what we did, we just changed these to 0. Is it? We just changed these to 0. It was in Gauss elimination. But in Gauss-Jordan elimination, as you see, we changed these both to 0. We changed both lower and upper triangular matrices to 0. That's it. Look at this. Let me check if this changed to, yeah. Here we have this system. It says solve this linear system by using Gauss-Jordan elimination. What we do first in Gauss-Jordan elimination and Gauss elimination, in the first step, we must write down the augmented matrix. The augmented matrix is the matrix that we get from the coefficients of the variables and the constant terms. This is the augmented matrix. Now, what we do, you can interchange these two rows, okay, as we did before. What we say, we need to convert this matrix to reduced row echelon form. One of the conditions of reduced row echelon form is that the leading entry must be 1. The leading entry must be 1. So if the leading entry of the first row is not 1, and there is any other one here in this column, you can swap 2 rows to change this to here. Okay? As you see, we have this one here. So we swap this row and this row to move this to up and to change the leading entry here to 1. So the leading entry must be 1. Okay? We swap these 2 rows. So row 1 and row 3. We interchange them. We interchange all the elements of row 1 and row 3. So after interchanging these 2 rows, this leading entry becomes 1. Is it? Let's see what we get. That's it. Interchanging this row with this row, we get this. Look, this row comes to down and this goes to up. Why do you do that? Because you want to convert this matrix to reduced row echelon form. To reduced row echelon form. To convert to reduced row echelon form, this must be 1. Either divide this by 2 or interchange these 2 rows to change this to 1. Okay? But it's easier to interchange those. By dividing the first row by 2, we get fractions, and dealing with fractions is not so easy. Okay? It's not too easy. So easy. Here, if we interchange row 1 and row 3, we get this matrix. This is the matrix that we get after interchanging rows 1 and 3. Then, what we do? We say the column that we have leading term in, all the other elements must be 0. It's one of the conditions of reduced row echelon form. In this row, in this column, this is the leading entry. This is the leading entry. So all the other elements must be 0. These elements must be 0. Okay? That's one of the conditions of reduced row echelon form. How to change this to 0 and how to change this to 0? By using this one, we change them to 0. Okay? By using the first row, we change these two to 0. How to change this one to 0? It's in which row? It's in row 2, is it? This one, this entry that you want to make it to 0, it's in row 2. That means row 2 becomes row 2, then minus 3 times what? Row 1. We make this to 0 by this one, by the leading entry row. Okay? The leading entry is in the first row. That means from row 1, we make this to 0. Okay, minus 3 row 1. Let's write down what we get. We haven't made any change in row 1, so we write down the same. 1 minus 4, 2, then minus 1. Okay, and then in row 2, what we did? We multiplied row 1 by -3 and we added to row 2. If we multiply row 1 by -3, what we get? -3, 12, -6, 3. Is it? Now we add these entries to row 2, adding this to row 2, adding this to row 2, and adding this to row 2. Okay? -3 plus 3 is 0. 12 plus 2 is 14. -6 minus 1 is -7. 3 plus 4 is 7. Okay, that's all. Look, this must be 0. If it's not 0, means you did some mistakes. Okay? Because we are trying to make this to 0. If it doesn't become 0, that means you did some mistakes somewhere. Okay? Now we did all the operation with row 2. Now for row 3, okay, we need to change this to 0. How? This is in which row? Row 3, is it? Row 3 becomes row 3. Then from this one, we want to change this to 0. What should I multiply by this one and adding to this to get 0? Minus 2 R chant 1 R1. Now we multiply R1 by -2. We get -2 here. We get 8 here. If we multiply these by -2, this one by -2 is -4. This by -2 is 2. Now we add this for the last row. It's 0. Then 8 plus 1 is 8 plus 1 is 9. Sorry. Then -4 plus 1 is -3. 2 plus 7 is 9. Look, we did 2 steps in the same step. Okay, you can do that. And also, you can do each step separately. And you can do, first write down this again here, and then do the second step in the next step. Okay, as it's done here. Look, yeah, it's done both at the same step here. These two makes to 0, and you get this. Okay, now what we do here, it's okay. Now this becomes 0. Then we go on to the next leading entry. We go on to the next leading entry. What's the next leading entry? We come to here and then go through the elements. We get 14. This 14 is the leading entry. So what if this is 0 and this is 9? What should we do in this case? We have to swap them and then do it. Okay? because the leading entry for this row is here, but for this row is there. It's not correct. The leading entry of the below one must be in the right of the above. Okay? Sorry? Yes, you can swap. You can swap how many times you want. Okay, you can apply an operation on the rows or columns. We just apply the operations on rows. You can apply any of the operations, as you have 3 operations, more than once. Okay. Now, what we do, the second leading entry is 14. And first, we need to change this 14 to 1. It must be 1. Okay? As we said, all the leading entries must be 1. After changing it to 1, then we change all the other elements of that column to 0. This is 14. How to change this to 1? By dividing by 14. We say row 2 is 1/14 row 2. Okay? Becomes, it's not equal, becomes 1/14 row 2. Let's see what we get. We get 1, -4, 2, -1. Okay? And 0 dividing by 14 is still 0. And 14 dividing by 14 is 1. -7 dividing by 14 is -1/2. Is it? Then 7 dividing by 14 is 1/2. Okay? How about row 3? Still the same, because we just did some changes on row 2. 0, 9, -3, 9. This is the step. We changed the second leading entry to 1. Now, what we do? By using this, one. By using this, we change this and this to 0. That's all. That's the second step. And then we change this to 1. After changing these two to 0, we change this to 1, and then we change these two to 0 by that one. Let's do this first. That's the step that we did now. Now, from this one, we change this one and that one to 0. First, let's change this one to 0. Let's change that -4 to 0. We say R1 becomes R1, then what should I multiply to this and adding to this to get 0? 4. It's R1 plus 4 of what? 4 times what? Row 2. It's row 2. As you see, this leading term is in row 2. Okay? Now, row 1 becomes row 1. Row 1 becomes, let's multiply row 2 first by 4. 0 times 4 is still 0. 1 times 4 is 4. -1/2 times 4 minus 2, is it? 1/2 times 2 is 2. Now, we add these to row 1 elements. It's 1. 4 minus 4 is 0. minus 2 and 2 is 0. 2 minus 1 is 2 minus 1 is 1. Okay. Then how about row 2? Have you done any change in row 2? No. It's still the same. We don't make any change in row 2 because the leading term is in row 2. So row 2 is the same, 0, 1, minus a half, and a half. Then how about row 3? As I said, we changed these two to 0. We did it, but we need to do this also. How to change this to 0 from this one? We say row 3 is row 3, then what should I multiply to this and adding to this to get 0? Minus 9 of what? Row 2. Now, if we multiply elements of row 2 by minus 9, we get 0, we get minus 9, we get 9 over 2, because it's minus half, times minus 9 is 9 over 2. And this one is minus 9 over 2. We now add these for row 3 elements. 0 plus 0, still 0. Now, minus 9 plus 9 is 0. Look, we did what you wanted to do. We wanted to change these two elements to 0, so we did it. Then 9 over 2 minus 3. 9 over 2 minus 3. It is 3 over 2. Then minus 9 over 2 plus 9. It is 9 over 2, is it? It is 9 over 2. So it is the matrix that we get. But you don't need to write down these in exams. Okay? That's it. This is the matrix after applying these two operations. Now we have this matrix. We have this matrix. What we do? We need to change this entry to 1 because it's the next leading entry. Look, this is the first leading entry that you worked on and changed these two to 0 by. Then the second leading entry is this one. And worked on and changed these two to 0. So what's the next leading entry? Yeah, 3 over 2. Yes. This one is the leading entry. What should we do first? We need to change it to 1 and then change these two entries to 0, but this one already is 0. So we don't need to work on that one. So we just need to change this to 0. Okay? But first, we need to change this to 1. We need to change this to 1. How to change to 1? We say row 3 becomes, yeah, it is 2/3 row 3. Look, 3 over 2 multiplying by 2/3 is 1. Look, generally, if we have A over B, if we multiply it by B over A, it is 1. Okay, it's for fractions. Here we have 3 over 2. So 2/3 multiplying by 3 over 2 is 1. Now, let's see what we get. After multiplying the third row by 2/3, we haven't made any change in row 1 and 2. We write down all the elements of row 1 and 2 the same. 1, 0, 0, 1. 0, 1 minus a half. Then 0, 0. Look, if you multiply 0 by any value, it's still 0. Then 1, and if you multiply 9 over 2 by 2 over 3, 9 over 2 times 2 over 3. These two are cancelled out, and these two become 3. That's it. We get this matrix. We get this matrix. After obtaining this matrix, now we try to change this to 0. We try to change that to 0. How to change this entry to 0? This entry is in row 2, becomes row 2. How to make to 0 from this one? Yeah, by 1 over 2. Which one do you multiply by 1 over 2? Row 3. Yeah. Plus a half row 3. So we multiply row 3 by a half, then we add it to row 2. If we multiply row 3 by a half, 0. This is 0. If we multiply this by a half, we get a half. Multiplying this by a half is 3 over 2. Then we add these to row 2. If we add these to row 2, row 1 is the same. 0 plus 0 is still 0. 0 plus 1 is still 1. A half plus minus half is 0. 3 over 2 plus a half is 2. Okay, it's 2. And the last one is still the same. We get this matrix. Okay? Sorry, after doing this, after doing the operation, we get this. Now, what are these coefficients? These are coefficients of which of the variable? X1. These are X2. These are X3. And the next one are the constants. Then look, here it means 1 times X1 is equal to what? To 1. So X1 is equal to 1. Then 1 times X2 is equal to what? 2. Then X3 is equal to what? 3. Look, we got the same result as we did before by using Gauss elimination. So if there's not mentioned the method that you should use, you are free to use which of these two methods for solving the linear system. And in both cases, you must get the same result. In both cases, you must get the same result. Okay? And this is Gauss-Jordan elimination. It takes more time. Okay? Gauss elimination is easier. In Gauss elimination, we just try to change these to 0, and we use the back substitution to get the values of x1, x2, and x3. Look, this is the same example as we did before by using the Gauss elimination. Here, the number of equations is 3, and the number of variables is 4. In this case, we assign the parameters. We assign the variables as parameters. Which of the variables? The non-leading variables. Okay? The non-leading variables. Only the non-leading variables. Now, we use Gauss-Jordan elimination. First, we need to write down the augmented matrix. This is the augmented matrix. Okay? Then, from this entry, we try to make these two to 0. Okay? We did it before. That's why I'm not going to do it again. Okay? We try these two to make to 0. We get this one. We did up to here in Gauss elimination, and from this we used back substitution. Okay. Now, what we do in Gauss-Jordan, this is the leading entry, and all the elements in this column are 0 except the leading entry. Then what's the next leading entry? This one. Okay. It's already 1, so we don't need to make it 1. It's already 1. Now, these elements on this column must be 0. The below one is 0. And we need to change the above one to 0 also. We need to change the above one to 0. Okay? We say row 1 becomes row 1. Look, never multiply that row that you want to make changes in by any value. You just need to multiply that row in which the leading term is in. Okay? We multiply this row by a value and adding to there to get 0. Okay? What we do, it's row 1 minus 3 row 2. Doing this, sorry, we get this. As you see, that becomes 0. Now, as you see, we have 2 equations and 1, 2, 3, 4 variables. We have x1, x2, x3, and x4. We have 4 variables and 2 equations. And then what we do, we just select the non-leading variables. What are the leading variables? These 2 are leading entries. And these are the coefficients of what? Of x1 and x3. So these 2 are leading variables. We don't assign them as parameters. How do you know which one is leading variable? Look, as we said before, these are the coefficients of x1. Okay? As we have leading entry here, that means x1 is leading variable. Okay? This is x2. We have no leading entry here. Do you know how to find the leading entries? Okay. Look, we go through the row. The first non-zero entry, this is the first non-zero entry in this row. So this is the leading entry. These are not leading entry, even if they are not 0. And in the second one, this is not leading entry because it is 0. And this is not leading entry because it is 0. So this one is, because this one is the leading entry. But here we have no leading entry. Okay? This leading entry is for x1, is it? But for x2, we have no leading entry in this column. Okay? x2 is not a leading variable. For x3, is it leading variable or not? Yes, because we have leading entry in this column. For x4, do you have? No. So the leading entries are, the leading variables are x1 and x3. And the non-leading variables are x2 and x4. We assign x2 and x4 by other by parameters. We let x2 to be s and x4 to be t. We let them to be s and t. If x4 to be t, here, this equation is 1x3 plus, as you see, it's x3, and 1x4 is minus 2. And if we replace x4 by t here, x3 is -2 minus t. Is it? Forget this. This x3, and you already have x1, x4. How to get x1? We just need to find x1 because x2, x3, x4 are no. Okay? You found x1, x2, x3. What else should you find? We need to find x1. Can we get x1 from this equation? No. We need to use the first equation to get x1. Sir? Yep. The 0 and the number x2. So when we go to that row 2, x2, and we have leading number? Yes, it could be. For example, here you have, let's say, 5. Any number. Yeah, it could be any value. Yeah, it could be any number. It could. I said non-zero entry. Non-zero entry, it means it could be negative, it could be positive, it could be any value except 0. No, for all the entries, I mean, even for the leading entries, even if this is 4, so the leading entry here is 4. In the process, you need to change to 1. In Gauss-Jordan elimination, you need to change to 1. Okay? The process makes it to 1. But in the Gauss elimination, look, if we return to Gauss elimination, this is Gauss elimination. In the case in which the back substitution is applied. Look, this is 14. This is 1. This is 3/2. These are leading terms. Okay? But in Gauss-Jordan, this in Gauss elimination. But in Gauss-Jordan elimination, the process makes the leading terms to 1. In the process, we must make it to 1. Okay? That's it. To get the value of x1, we say 1x1 plus 2x2 plus 0x3 plus 1x4 equals 16. We replace 0x3, we have no x3 here. Okay? x2 is what? x2 is s. So it's x1 plus 2 times s, because we have 2x1. Then x4 is s1, x4. x4 is t plus t equals 16. So x1 is 16 minus 2 is minus t. This is x1. And you already found x1, x2, x3, and x4. And these are the solutions. You say x1 is this. x2 is this. x3 is this. x4 is this. This is the solution. And you already solved this by Gauss elimination, and you got the same results. As I said before, if you use any of these two methods, you must get the same result. You must get the same result. Yeah. That's all. That's all. That's the solution. Okay? That's the solution. It's asking about that. And this is another example about Gauss elimination. It's easy. Okay, it's enough. So this example is for yourself. This example is for yourself. It's the same as the previous example that we did for by using Gauss Jordan elimination. Gauss Jordan It's Gauss-Jordan elimination. Then we have factorization, matrix factorization for next week.